Okay, hello, good day everyone. My name is Adrian Putra Perdana, and today I'm going to present my final project of machine learning, and the task is about the clustering. So here is the table of content. We have 5 chapters, and we continue to chapter 1, introduction. So first is the problem. Given a data set, from the dataset, we must do tasks on the dataset, which is clustering. From clustering tasks, we must provide 2 models and 1 evaluation for each model. So basically, the task is to predict whether whether the customer is interested to buy a car or not based on the uh, customer data in car dealer. We continue to method. There are 4 steps to solve the problem that has been reviewed. So first one is data preparation. Is the process of transforming raw data so that data scientists and analysts can run it through machine learning algorithm to uncover insight or make prediction. The data preparation process can be complicated by issues such as missing or incomplete records, outliers or anomalies, improperly format or structured data, inconsistent values, and non-standardized categorical variables, and limited or sparse features or attributes. Second method is modeling. The outputs of prediction and feature engineering are a set of label times, historical examples of what we want to predict, and features, predicting variables used to train a model to predict the label. The process of modeling means training a machine learning algorithm to predict the labels from the features. The third method is evaluate the model. Model evaluation is an integral part of the model development process. It helps to find the best model that represents our data and how well the chosen model will work in the future. And lastly is conclusion. Summarize the report as a wall drawing inferences from the entire process about what has been found or decided and the impact of those findings or decisions. So we continue to chapter 2, which is the data pre-processing. So firstly, we need to upload the data set and show the data frame. As we can see, this is the data that has been put into the data frame. And the next thing we need to do is to check whether there is a null data or not in the data by calling on the pandas info method. And next thing we need to do is to drop the null data using drop nut. And here we can see the info after we drop the null data. We continue to chapter 3, modeling. So I used to model, but we only use one algorithm, but with different feature and different data preparation. We go to the first model. In the first model, I used 2 feature, which is umur and lama berlangganan. So next thing we need to do is the normalization. So I already put the feature to the data frame, which is called the cluster feature. and then we can normalize it with min max color. So this is the data that has been normalized. And next one is to know the optimal cluster. For algorithm, we use elbow method, and from the figure above, we can observe the point after which there isn't a sudden change, which is the k equals to 5. So this is the line that there is no sudden change, in my opinion. So I choose k equals to 5 as the number of my cluster. And then I create the centroid, where each centroid will be a centroid for one cluster. This is the algorithm for centroid, and the output of the algorithm will be in a dictionary with cluster number as keys and the data points which belongs to that cluster values. So I initialize the dictionary with the output assigned to parentheses. The next thing we need to do is to find the Euclidean distance from each point to all the centroids and store it in a matrix. So every row in Euclidean distance matrix will have distance of that particular data point from all the centroids. Then find the minimum distance and store the index of the column in a vector C. So this is the Euclidean distance, and then we regroup the data points based on the cluster index C and store in the output dictionary, and also compute the mean of separate clusters assign it as new centroid. And then we repeat the previous step, but this time using looping with 25 iteration. We use 25 iteration as a random number. And this is the step which is we use. Also, we use the previous step. And the next thing, we can finally plot the visualization data. So this is the visualization of unclustered data. And this is the clustered data. I also put color for each cluster, and the yellow one is the centroids. So we go to the second model, and in the second model we use two feature, which is umur and kode daerah. First, put both feature to the data frame data C. Just like in the first model, but here the data preparation is I encode the data, so they will not have. I will separate the comma. I mean to remove the comma from the data, and then put it into array. So just like the first model, we need to know the optimal cluster for the algorithm we used elbow method. From the figure above, we can observe the point after which there isn't a sudden change is k equal to 5. So I choose k equal to 5 as the number of my cluster. And the clustering process is the same as the first model. Like we need to find the Euclidean distance and so on. And so the result of the unclustered data is this. This is the visualization. And this is the cluster data for the second model. The data visualization might be look messy because there is a lot of data which is about more than 250,000 data. And we continue to chapter 4, which is the evaluation. And because we use k-means for both of the clustering algorithm, the evaluating method that I use is elbow method and silhouette analysis. In the first model, I use the feature is umur and lama berlangganan. To do the evaluation method, I import my data frame to array. The first method is elbow method. As we can see, this is the algorithm for the elbow method, and this is the data visualization, and we get the k is 5, and the second method is silhouette analysis. Silhouette analysis is a way to measure how close each point in a cluster is to the point in its neighboring clusters. It's a neat way to find out the optimum value for k during k-means clustering. From the figure above, we can see that the average silhouette score is 0.3906 for the first model. And for the second model, I use the same method, but with different feature. I use umur and kode daerah, and also different data preparation. As we can see, in the first model, I use normalization, but in the second model, I did not use normalization, but I used the label encode. And this is the same elbow method like the first model. And elbow method is to know the optimal cluster for the algorithm. And this is the silhouette analysis. So the average score is 0.4618 for the second model. And for the chapter 5 conclusion, from the score that I got from the accuracy score of the evaluation of clustering, we can conclude that my data is not good enough. And also we can conclude that the more good and the more true the developer in performing data analysis, then the result will be slightly better. Suggestions that I can give for future improvement are the developer should focus more time on performing data analysis and cleaning the data in order to build the model more efficient. The developer do more research of how many iteration is the best for clustering. And this is my code. I use Python. This is the library and the data preparation. And this is the clustering for the first model. This is the elbow method. And we create the centroid and to find the Euclidean distance. And this is the visualization of uncluster and cluster data. And this is the evaluation. I use silhouette analysis, and it is the same for the second model, but different data pre-processing. Pre-processing. I use silhouette analysis as well for the evaluation. So I think that's all from me. Thank you very much.